Welcome to this video. In this video we're going to talk about how to implement pagination using Spring Webflux. So why this video appeared is because the pagination with Spring Webflux is a little bit tricky, especially when you use router functions, because Webflux does not have the same convenient pagination API as Spring MVC did, and therefore you need to do things manually. But in the end of the day, it is our job as software developers. So first thing first, let me review what is a pagination, so to ensure that we're on the same page. Here you could find a definition that I found on techtarget.com website, and it states that the pagination is a process of separating print or digital content into discrete pages. As a web user, you definitely have experience with pagination on different websites and web applications, when you have a list, a table, or grid of items, and you have just a chunk of all data, and in the bottom of this list, grid, or table you have buttons like previous and next, and you have a list of numbers that allow you to quickly jump to the specific page. So it's the technique that really will emphasize the better user experience. Also, the pagination would be used in the same strategy, which is called infinite scrolling, which also allows us to enhance user experience, but it's a bit different from a client-side point of view. But from the server-side point of view, basically the process is the same, and you could reuse the same API as we have here. But before, let's review how actually pagination does work. Okay, so here you could see how does the pagination flow work from the helicopter point of view. So in this way, when the pagination is enabled, the client would add 2 additional query parameters to the criteria of the GET request. So the first one would be limit, and the second page. So it is important to remember that the pagination criteria are distinct from what is called search criteria, because search criteria are based on a business domain. For example, you could get items for user ID or any other search criteria that depends on a business domain. And this pagination criteria, they are not actually a search criteria, but they are used by the server in order to cut only those results from the search results that you want to return to the user. For example, if we have a limit of 10 and a page number 2, that means that we get items from 11s to 20s. So let's briefly also check how we could calculate this pagination parameters. Okay, let's have a practical example. You see here that I have 14 items that are separated on 3 pages. So the first page will have 5 items, second page also 5 items, and the final third page will have only 4 items. And this is important to understand, because this is how pagination does work. It will have 16 items, that means we will have 4 pages, so we'll have also 5 items on the page 3, and the final 16 item would be on a separate page number 4. So how do we actually calculate this? So we have a formula, we have a number of a page that we want to get, and we have a limit. So how many items could be on the page? In this case, the pagination limit would be 5. So let's take a look on the starting item of the page number 3. So we have a page number, we need to subtract 1 from this, and we need to multiply its pagination limit, and finally we add 1. So let's take an example. So we have a page number 3, which is 3 minus 1 would be 2. We multiply it by 5, we will have 10, and finally we add 1, and this means that 11th would be the first item of the page 3. And then we also use limit in order to get only 5 items from 11th to 15th, but we have here only 4 values, and we will have only 4 items on the page number 3. So this is how we could calculate pagination, and let's see how we could also implement the pagination and where we could allocate it in the Spring Webflux applications. Okay, where could we implement the pagination? Well, when we talk about traditional web frameworks such as Spring MVC, Laravel, Django, etc., we actually don't have this question, because pagination is implemented continuously throughout all layers of your application. a data layer, on a service layer, on a web layer. However, when it comes to REST API development, the problem here is that we have what is called stateless API. So we don't have this ability to track pages and pagination like we do it in sessions with traditional frameworks, and therefore we could ask ourselves where we want to implement the pagination, because it could be implemented not on all layers of our application, but only on a single layer of our application. And typically we could have here two answers. The first one would be the data layer, and the second would be service layer. So when we talk about data layer, it's a bit tricky, because yes, we could use Spring Data repositories with Webflux, and we could pass the additional argument of type pageable to methods alongside with search criteria. However, we heavily depend on Spring Data Magic, and the second problem is that we do not have ability to count all items of search criteria, which is important in order to provide a better user experience. And also the third reason, if we want to provide additional computations on the service layer, we will not be able to do it, because we already have a paginated and separated items in the response of the repository layer, and therefore we could use the pagination on a service layer. In this way, the data layer component or repository would only return you information based on a search criteria, but not a pagination criteria, and then we could use either flux, skip and take methods, or we could, if we have a list, we could use skip and limit methods that are available via Stream and Java collections framework manipulations in order to do pagination on the service layer. So basically it is important to remember also about the following facts. When we talk about pagination on a data layer, we use methods that are implemented in the database. So if we talk about, let's say, SQL databases, we have the limit and offset function that allows us to do pagination on a database service. When we talk about service layer, we do actually pagination on our application service, so we'll do it on the side of our application. So you need to remember this if you want to tweak performance of your application, so where does the pagination would actually happen. So without further ado, let's jump into implementation of our pagination with Spring Webflux. Okay, before we'll be ready with an implementation, let's do some preparation work. In our project we have a class called nodelist.java. Let's go there. So, as you could see, this class is basically an implementation of list view pattern. In other words, when we return a list of nodes, we do not return just a list of nodes like we do in a Spring by itself, but we will return this additional abstraction. And why do we do this? Well, I do this for the reason, because with this additional abstraction, what I could do, I could provide additional parameters to the output so they will be ready to use by the client. And namely, what I would like to add here, I would like also to add another parameter, would be integer, and I call it total. So what does it mean? This means that we have also an additional number, what means the total number of nodes that is available in the database. So, in other words, when we have a list of nodes, this one, and we provide a pagination, that means that we have only a limited fraction of all nodes, and we would like also to know all other items, because we would like to provide a better user experience. So we would like to demonstrate how many pages, how many items are remaining in the output, etc., etc. Well, all other parameters we could calculate on the client side, and this number, this total value, is not possible to calculate because we actually need to know it beforehand. So let's save it, and let's go to the nodeservice.java contract. And what I would like to do here, I would like to provide additional function here that we will use throughout this video. So let's copy this last line of code, and let's copy and paste it, and let's call it find all nodes and paginate. And I would like to provide here two additional variables, two additional arguments. The first one would be a page, and the second would be a limit. So this would be those two values that we could capture from query parameters of the request like we saw before. So let's save it and let's go to the node service implementation.java, and what I would like to do now, I would like to implement this method. So now it is ready to use throughout this video. Also here we have this node list instance that is created, and as you remember from the abstractions that we did before in this subsection, we need also to provide a total number of values. In this case, what we could do, we could specify here a list size as a second argument, because we don't provide any pagination here. So let's save it. This is now project that is provided for, this is prepared actually for implementation of our solution. So let's start with them. Okay, our pagination flow will start on the request response handling function. So in this way we need to go to the handler class. In our case it will be node handler.java class. So we go here and let me maximize the screen so you could see the whole editor. And what I like to do, I would like to create another method that will called let me provide first a return type, and it's called find all nodes and paginate, and it also will get a server request argument like all handler methods in Spring Webflux. So like in the previous one, of course we need to get a path variable called user ID, and then we need to provide also two other values that will be query parameters. So the difference between path variable and query parameters is that path variable is required and query parameter is optional. In other words, if we have query parameters of limit and page, that means that we have pagination. Otherwise, we just return a whole list of items like we did in the find all nodes method in the previous case. So in other words, we need to provide simple if-else statement, but before we need to get values of query parameters. So in Spring Webflux, they are optionals and we could get them. We provide here a type of integer, and the first one would be page, and we could get it by using request query parameters, and we provide a name. The first one would be page. So a query parameters is basically a string, so we need to provide also a mapping operation. So we say integer value of, and the same way we do for another query parameter, which is limit. So the same way we do query parameters, but we call it limit, and we also do a mapping operation. And we need to provide a type conversion between string and integer. So important to remember that this optional could be empty. Another way, if we don't have page and limit, nothing would happen. So they would be both empty, and therefore we don't need to provide a pagination. So then we provide an if-else statement. So we say if page is present and limit is also present. So in this way, what we do, we will return this find and paginate method that we have here as find all nodes and paginate. So we say find all nodes and paginate. Otherwise, we will provide this same line of code that we have here. So we just copy and paste all this code here. So we say find all nodes. Even we don't have a pagination here in the second case, we still need to provide to the client this information. Another way, we need to say to the client that the pagination is not enabled. Well, it's obvious for us humans, but we need to tell this explicitly for the application. And how we could do it? Well, in the world of API development, what we could do, we could specify a response handler. So we could have not only request handlers, but we also could specify handlers for responses. So how we could do it? Let's add here after the and before the content type after the OK, we could specify another method that is called header, and we specify first a name of the header, which would be xApp pagination enabled, And header values in Spring Webflux should be strings, not an object like in other frameworks. So we need to provide it inside the quotes. So we say here false. And also do not forget a quotation mark after. So now we have this header that will indicate to the client that we don't have a pagination, and this naming convention, starting with XApp, is basically quite a standard that is used in API development world. So now we finished with this not paginated handler, and let's go to the find all nodes and paginate handler, so when the pagination is enabled. So the same idea that goes here. So we say return service, but we call a method called find all nodes and paginate, and we specify user ID, then we specify a page. We could use it by using a get method of the optional, and because we already done this this checking, it's safe to use this method, so we have a value. And next would be a limit get, and now we could do the same stuff we did before. So we could just copy this line of code that we have here, and we could copy and paste. But do not forget to change the value of the handler here to true. And now we have the handler implemented. And now what we could do, we could demonstrate both solutions that we described in the theoretical introduction of this video. And let's start with the implementation of pagination on a data layer. Okay, as I've said, the first implementation would be a data layer implementation. So it will be only for demonstration purposes. We will not use this throughout this video. However, it's still important to provide it. So let me again open a file explorer and go to the node repository class here. So what I would like to do, I would like to add another method. So here we will use this Spring Magic, and we will use again a Flux return type. And we call this method find by user ID, because we want find by user ID obviously, and we will provide an overloaded version. So the first the first argument, would be the same as an original method, and the second would be a pageable. So we use this from Spring Data, from this Spring Data package, and we call it pagination. So now we could use this overloaded version in our service. So let's go to the service implementation, and here let me return repository find by user ID, and we use this second version. So the first argument would be user ID, and the second would be of type of page request, which has this static method of that accepts two values. The first one would be a current page of the pagination, a second is the size of the list. So in other words, it would be a limit argument. So now we do the same stuff as we did previously. So we do mapping, and we use here a list, and we create a new node list, and we provide here a list. And as you could see, we don't have actually a value for the total number of items, because we are not able to get them. What we have from the database is basically already a paginated version, so we're not able to use it in the Spring Webflux. Unlike Spring MVC, when there is a page method that is used for pagination. However, in the Spring Webflux, it's not possible to do, and we just put here a 0. And things that I would like to stop here is to just comment out this method, because we will not use it, and instead we will concentrate on a service layer pagination. Okay, service layer pagination. Let me first reuse the same line of code that we have here in find all nodes, but we will modify it. So instead of this one-liner, we will provide actually a code block of several commands. So let's provide curly braces here. And what I'd like to do, the first thing first, I would like immediately capture a total number of items. And because here, by using this find by user ID method, the original method, we immediately have all items, we could safely save this total number. So we say integer total, and we say here list size. So now what we have a total number of items. The second thing is, if you recall the previous slide about calculating a start value, we will calculate a start number. So how we could do it? So in order to do this, we have a page, and we subtract 1 from there, and we multiply it by limit value. So now we have a start position. So what we could do, we could now use Java streams in order to cut this whole list and only provide a fraction of it. So how we could do it? So we create another list variable, and let's call it nodes. And what we'll do here, so we use the original list, and then we use a stream, and we use skip intermediate methods. So the skip would be here value of start. So we provide another way, we provide a first value of this new list. So in other words, by using the skip methods, we tell to stream how many positions we would like to skip. So it will be like the last item of previous list. Sorry. So, and then we use a limit, which is self-explanatory. So finally we need to use a collection terminate operation. So we use here collect collectors to list. So now we have this original list, and what we could do, we could create a node list, called it results, and we create a new node list. And now we could provide here a node and a total. And finally, all what we do, we return this result. So now we have here this logic, and we could now test it. So far so good. So let's add some automated tests in order to verify the logic that we have just implemented. So the first one would be a test for the service layer, which is called not service implementation test.java. And what I'd like to do here, I would like just to duplicate this last testing method. So let's copy and paste it, and let's rename it to find nodes and paginate. And what I'd like to do here, we have here 5 nodes. So let's make 15 of them. So now we add additional 5, and finally we have another 5. So now we have 15 items, and I would like to paginate over this list to have just chunk of this data. And here you could see that in the Mockito specification method that we have here, we actually return all items from the database, because remember, we do pagination on the service layer. So on the service layer, instead of using find all nodes, we use find all nodes and paginate, and we specify a page. Let's say it would be 2, and we also specify a limit, let's say 5. So we basically want to have items, so we have first, second, third, fourth, fifth, and from this one up to 10th. And we also, as you remember, the node list, besides the list of items, we will also have here a value called total. So instead of just one assertion like we have here, so let me put here a curly braces, and let me add another assertions here. So let me a bit format this code, and we'll say assertions, assert that, and we also have here a result total value, and we want to check that it is equal to 15, because we have 15 numbers of nodes at all. So let's run this test. And now you could check that this service layer test is successfully passed. Okay, the same way we could provide also a test for the API layer, but there is one thing that we need to do before. So let's go to the node handler class that we have. As you remember, we have here a new method that's called find all nodes and paginate, and we need to make sure that the router will actually call these methods when the get endpoint would be triggered. So let's go to the router class, so say router.java, and let's replace this find all nodes with find all nodes and paginate. So now we could go to the API test, and first thing first, we need to ensure that this original test, find all nodes test, is passed without any problems. So let's run this test. and we could check that this modification does not provide any harm for our implementation, which is actually a goal of unit testing. So we need to provide this unification. So let me maximize the screen of the code editor, and what we need to test here, in addition to the status and the body, we also need to check a header. So as you remember, inside the node handler we have here this XApp pagination enabled header, and we also would like to check that this header is presented and it's either true or either false, which depends on the pagination. Does pagination is enabled or not? So let's go back to API test, and in this original test we don't have any pagination and we expect this header to be false. So we call here expect a header method, and we specify here a method called expect value equals of course, and we provide the name and the value. Remember that the values are strings here in Spring Webflux, we say false. So now let me run this test, and you see that the test is passed. So we also, let me maximize again the screen. We could also provide another one method, but for paginated version. It would be a little bit tricky because we need to supply query parameters, but again it's not so hard. So let me create another method. We called it find all nodes and paginate test. So we have here a user ID, we have here a list of nodes, and we have here a behavior of the service. Because we actually mock the service, we don't need to change anything here. So we could just reuse the same code like we did here, because we don't have any logic that's specific to pagination on the service layer tested here. But then what we need to do, we call here client get, and we need to provide a URI. But remember that URI here should be not a URI like URI object, but we need to use a builder function, because what we need to do, we need to be able to provide query parameters, and this is possible only if we use builder. So we say here builder, and here we have this function, so say builder, and there are several methods that we could use in order to build. The first one would be pass, and this will be original strings that we have with a pass variable, so say nodes user, and then we specify also a query parameters. So the first one would be a page, and the second would be a query parameter that is called limit, let's say of 5. So we also need to change here to find all nodes and paginate, and the page would be 2 and the limit would be 5. So this way we enable a pagination on the service layer. So what we could do now, and don't forget to use a build actually, of course. Now what we could do, we could use the same code like we did. So accept, exchange, expect status, a header, a body, and all of this stuff. So let me copy all these commands. And now we have the same logic, but we need to remember that we should not only have this except pagination enabled to true, and here we will provide several assertions like we did on the service layer test. So here what we have here, the first one will be assertions for the nodes list, and the second would be assertions, assert that, and we need to check also the total value, of course not hash code but total, would be is equal to 5. So now let me run this test and check how it would perform. And you see that this test is passed. So we have completed all automated tests, and now we're ready to test it using our web client. So now we're ready to run this application and see how it would behave. Okay, so now I'd like to test my implementation using the API client. For this I need to run my application, but before I need to run a database. So let me go to my terminal, So let me select my terminal, and I would like to use a Docker in order to run a MongoDB container. So let me execute command that's called docker run. We'll specify port mapping, and then we specify name of the image, so it would be Mongo latest. By the way, if you're not familiar with using Docker, I highly recommend you to check my Docker tutorial, which is also available on my YouTube channel. So let's run this container. And now we have a MongoDB running. So let me go back to my VS Code. And here I have this Flux Node application class with the main methods. So let's run application. And now you see that application is up and running, and let me go to my API client. I use Insomnia, but you could use Coral or you could use Postman. So first thing first, let me add some nodes to the database. So the first one would be with the user ID of user1. Let's say here this is my first node. So now it is presented in the database. Let's add several else. So we have second one, we have third, fourth, fifth. Basically, we need just to have more than 5, or in my case, because I have a limit of 5. If you have a limit of 3, of course, you need just to have 4 items in the database. But let's say we have here 7 items. So next, when we go here to find nodes by user, so it will specify here user of 1. So we should have here 7 items. But if we also go to headers here, we need to check that, sorry, not here, of course, but headers here, we would check that except pagination enabled header is equal to false. But if we use query parameters as well, so, and here we need to go to the left panel. So the first one would be a page, and let's say page would be second page, and the limit would be of 5. And also you see that here we have this total value of 7. So let's execute this request, and now we have here only 2 items, but we also have here the total number. Still we have a total number of 7, which is used in order to indicate to the client that we have 7 values in the database. And if we go to headers, you see that except pagination enabled is equal to true. So we could now see that our implementation of the pagination with Spring Webflux is up and running, and this is how you could implement. So if you like this video, I highly recommend you to check other my videos, and if these videos will help you, I would be more than happy if you will share them, if you subscribe to my channel, or if you just put the like under this video.